Hi, welcome to Fremont Math Hub. Today, I'll be discussing with you all how to solve rational equations. I hope that with this tutorial, you'll better be able to understand how to simplify and solve for the variable in these equations. First off, I just wanted to get into the definition of rational expressions. Before we even talk about the equations, it's good to know what these are. A rational expression is a special kind of fraction in which you have polynomials in your numerator and denominator. Another way it is that you can think of these expressions is as a ratio of two polynomials. These polynomials can be very simple. They can also be pretty complicated. When we say polynomials, we're talking about expressions in which they involve variable, or it can involve a whole number. There can be all kinds of combinations. So for example, 2 over x. We have a variable at the bottom and a whole number up at top. These are technically two polynomials. There's one here as well, 3 over x plus 4, another simple one. But here's a more complicated one. There are variables both at the top and the bottom. This is your more traditional rational expression. Things that would be more considered to be polynomials at the top and the bottom. Now, the next thing it is to discuss in terms of solving these equations is I wanted to give you all a refresher in terms of the rules of adding and subtracting rational expressions. The same rules apply as when you're adding and subtracting fractions, which is probably something it is that you learned about when you were younger in grade school. All it is that you want to add and subtract are the numerators. And here's the key rule. You cannot add and subtract the numerators unless the denominators are the same. If they're not the same, you cannot move forward. So let's try this out. Take a look here. 2 over x plus 5x over x. Can we add these? Well, do the denominators match? They do. And so that means, to simplify this, you just combine them all under one denominator, because they're the same, x, and this would be your answer. What about this example? Can we subtract these? Well, the answer is no. The denominators do not match. So this is how we'd have to leave this. This is the most simplified. In the case of rational equations, though, there will be a lot of cases in which the denominators do not match. And what we have to do in those situations is use the least common denominator to our advantage. Rational equations are a mix of rational expressions being added and subtracted to one another and including an equal sign. So you'll have at least 3 terms. And so it's very important to make sure that all the denominators match because it'll make it so much simpler to solve. For an example like this, well, when you're usually solving for an algebraic equation like 2 plus x equals 5, it's simple. Subtract 2 on both sides, and then you end up with x equals some number. It's hard to do that with rational equations like this because you have variables in the denominators. It makes it complicated. So the way that you get rid of the denominators, again, is by finding the least common denominator. So what would it be in this case? Well, you look to see what they all have in common. If they don't have anything in common, combine them. Put them together. So more likely than not, multiply all the denominators within your equation. Just like this, 2 times x plus 1. However, it won't always be that simple. The other method is in the case where you have something like this. If you were to multiply all these denominators, you would have a huge, complicated polynomial, and it'd be really difficult to work with. So in this case, it helps instead to see if you can break down or factor the denominators in order to figure out what the LCD will be. So how do we factor? Well, there's a few different methods, and we don't have time to go through those today. But one of those methods will help us to break down x squared minus 4. That method is also known as difference of two perfect squares. And it breaks down into x plus 2 times x minus 2. This is the same thing as x squared minus 4. Can we break down x times x plus 2? No, we can't. That's already been broken down. It's factored. Can't do anything else. Now what about the rightmost term, x minus 2? This also is good. Can't be factored any further. So we look to see, do they have anything in common? And what do you know? They do. Two of the terms here have x plus 2 in common, the top and the middle. And two other terms, the top and the bottom, the first and third, have x minus 2. So because they have these in common, you can multiply these two as part of your LCD. But you're still missing something. You're missing any other terms within these three denominators that aren't included. So we already talked about x plus 2 and x minus 2. Well, the x isn't included. So we also multiply by that. So our final LCD would be x times x plus 2 times x minus 2, as shown here. Okay, let's actually go through an example of solving rational equations now that we have this framework. Going back to the first example that I discussed, we already said that the LCD was 2 times x plus 1. We just multiply all the denominators together. That's what they all have in common. What you do to get rid of the denominator in the end is multiply each term by the LCD individually. Just like this. 2 over x multiplied by the LCD. And I show this here in red. Okay. Now, if you look here, okay, again, here's why it is that you do this. The top and bottom now should have something in common to where the denominator should be able to cancel out. So the bottom here has an x, this has an x, denominator's gone. What about over here, the second term? Well, this has an x plus 1, so does this. That's gone. And then same for your third term. They both have a 2 on the top and bottom now. So that's gone. Your denominators have disappeared. And then what you can do is multiply everything else that's left over. It'll end up looking like this. We did 2 times 2. That gave us 4. And then x plus 1. We did 5 times 2. That gives me 10 times x. That's there. And then 1 times x. That is x with the x plus 1 on the side here. Okay, so each time you multiply by the LCD, this will happen. The denominators should disappear. If this isn't the case, go back. Probably means that you did something incorrectly. Now, in the case where all of your denominators match within your rational expression, or equation, I should say, sorry, you just cancel them all out and proceed with your numerators. So for example, I'll show you what I mean. In this case, if all the denominators matched, okay, we'll just cancel these out for a moment. If all your denominators matched here, well, my LCD would be x plus 1. They're all the same. If I multiplied each of these by x plus 1, all the denominators would disappear, and all I'd be left with is what's on top. 2 plus 5 equals 1, which is incorrect, by the way. But I'm just trying to make a point. Okay? All right, now moving on to step 3. We combine and we simplify. Again, we have 4 times x plus 1 plus 10x plus x, equals x times x plus 1. Okay, what do? Well, we can distribute to combine. That's a good place to start, just like this. So we'll get 4x plus 4 plus 10x equals x squared plus x. And then what can we do? We can combine like terms. Our like terms here are these two on the left side. That gives us 14x plus 4 equals x squared plus x. You should see here we have a quadratic equation, aka an equation where you have x squared, an x squared equation. To solve those, you want to make sure that it ends up equaling 0. So you want to move around things from the left side now to the right side, so that you'll end up with an x squared plus this equals 0 equation. When you move these things to the other side, you have to add or subtract to do so. We get x squared minus 13x minus 4 equals 0. Now, to solve an equation like this, you can either factor or do quadratic formula. There's different ways to factor. We talked about one of the ways earlier. But in this case, it would be best for you to do quadratic formula. None of the factoring methods will work for this kind of problem. Yes, none of the methods will actually work for this kind of problem, unfortunately. So you want to go ahead and quadratic formula. Here's the equation. A is the coefficient that's being, it's a number that's being multiplied by x squared. That ends up being 1. B is the coefficient next to your x variable. C is your constant. It's not connected to an x. Therefore, A is 1, B is negative 13, and C is negative 4. And you just plug these into this equation. Negative 13, 2 negatives make a positive. That's how we end up with the 13 there. B squared, that's negative 13 squared. That ends up being 169. Negative 4 times 1 times negative 4. That'll be minus negative 16. Again, 2 negatives make a positive. So we'll have 169 plus 16. That'll end up equaling 185. That now is underneath the square root. And so this ends up being our final answer. I hope that in going over this process, it allows you to better be able to solve rational equations. Thank you so much for your time.